Hello and welcome once again to Intro to Computer Games and Simulations here at Lorain County Community College. Mike Substelny here, the professor this term. We are back this week in the Game Design Workshop textbook. Today we're going to be covering in the third edition a little bit of Chapter 6 and a whole lot of Chapter 7. This is mostly about Chapter 7 prototyping games. I think you're going to love this week. It's certainly one of my favorite weeks where we get to play with some toys in the classroom. So, today, what we're going to cover is brainstorming and prototyping games. Previously, we said where they got the ideas for Farmville were they wanted simple games that people can easily set aside. And they wanted games that could be played in a tab of their browser while you're on a conference call. And they wanted to make the link between virtual goods and real-world social relationships in creating Farmville. Remember that lecture we talked about social games a couple weeks ago? Do you notice that none of the things they set out to do, none of the ideas they came up with had anything to do with farms? Farming wasn't where the idea for Farmville really came from. They wanted to build something that would accomplish those goals, and they came up with the mechanics and pieces of Farmville. These simple games that people could play that could easily set aside, played in a tab with your browser when you're at a conference call, and make that link between the virtual goods and your social relationships. And they were kind of the first to succeed in that in a gigantic way. All right, another game. We talked about it when we talked about, this was also social games. Keep Talking and Nobody Explodes for the Oculus Rift. Remember, we talked about that innovative game? In that game, the player is defusing bombs and doing other things wearing the Oculus Rift. Well, they found out that the Oculus Rift attracted an audience. And a lot of people would be around not wearing an Oculus Rift, just watching the person wearing the Oculus Rift playing a game. And that's a view of the person wearing the Oculus Rift. And they wondered what could they do to make it fun for that audience? How could they get them involved? And they came up with these books and books of instructions to pour through of how to defuse the bombs and solve the other puzzles and traps that the player wearing the goggles had to do. And it turned out that was a really fun game. So where do people get the ideas for games? We're going to talk just a couple of minutes about that. Csikszentmihalyi, our old friend Mihaly Csikszentmihalyi, described these stages of creativity. He said preparation was the first stage. You had to become immersed. The second stage was incubation. You churn out ideas subconsciously. Third stage is insight, when you receive that aha moment. And everybody in this room has probably experienced that. And then you evaluate. You put some criticism to your aha moment and say, is that aha valuable or is it a piece of junk? And then the long one, the elaboration, where you take those first three that are the, those first four where the idea comes from and turn it into the creative product. And that's the 99% perspiration part that Thomas Edison was talking about. Okay, today we're going to actually brainstorm some games. We'll do some exercises probably using sheets of paper in teams in the laboratory. So be prepared for that. It's going to be fun. When you're brainstorming games, you should follow these rules, and there are more in your textbook. Number one, don't criticize the ideas. There's no bad idea during brainstorming. The criticism comes later. No censoring during the brainstorming. Say anything you want. There are no bad ideas. Remember that? Even if that idea is grinding to grow melons, as in the case of Farmville. All right, today we're also going to prototype games. We're going to crack open the toy box, get some toys out, and play with them. Let's talk about the types of prototyping. All right, physical prototyping. Physical prototyping is where you use toys, paper, things like that to figure things out about the game. We're going to elaborate on that in a minute. There's also software prototyping. Your book has a whole chapter on software prototyping. We probably won't get to that chapter this semester, but we'll give you, you've already gotten some techniques for software prototyping just by doing your labs in GameMaker. And software prototyping is where you use a GameMaker, an Alice, a Unity, something like that, to quickly knock up a rough model of your software version of your game. There's also the visual prototype, which may use toys, may use software, may use both, that is just to get an idea of the look of the game. You can see in this case using model airplanes to get a feel for how the other model airplanes would appear in the game. And the main topic we're going to talk about this week is physical prototyping, and our lab exercise this week will be physical prototyping. Physical prototyping is a very useful technique for fighting games like massive multiplayer online role-playing games or real-time shooter games or first-person strategy games, things like that, things where there's some kind of physical conflict involved. It could also work for a race game, a chase game, a rescue game, an exploration game, all those other goals we talked about. Physical prototyping is usually less useful for puzzle-type games. I don't think it would be that, I mean, it could be fun to build a live model of Tetris, but it wouldn't be that useful in improving the game. All right, what is it useful for? Well, it's good for showing the relationships between units in a game, their positions and things like that. For example, in this picture, you can get yourself to think about, well, which units can see which other units in this case? The toys make that a very obvious question to ask. And you've got to work that out in the rules of your software game. Yeah, it'll make you think about what are the ranges of the weapons or other effects that these units might have on each other. What is the speed of the units when they're running, walking, ice skating, whatever your units might be doing? All right, in this case, we have a couple of tanks in a city-type environment with these paper buildings. And as the team is thinking about their game, they may become concerned with how fast can that turret turn? Because any second now, as these two tanks move, that's going to become important. Right now, they don't see each other. In a few seconds, they will. And the speed of that turret will probably determine the fate of that tank. All right, you should understand that figures can substitute for other things. Plastic soldiers that you can get at the dollar store, used to be a dime store, that you can get at the dollar store are very commonly used in physical prototyping. But they don't have to represent plastic soldiers. Yes, this could be a military first-person shooter that we're looking at here. Could also be a zombie apocalypse. No problem making those green soldiers all represent zombies. Sure. Or it might be a MMORPG where toys are representing other toys. That could happen. A toy MMORPG, there have been several of those where you play a toy. Or it could be a MMORPG with cartoons, and the cartoons could be fighting giant robots or something like that. Or it could be a single-player role-playing game where your figure is just representing the player, or the figures might represent giant robots that are fighting each other. And as you can see, the scale of this building and the scale of these figures, they're about as tall as, they're a little taller than one floor of a building. And on that same note, they could represent carnivorous dinosaurs or some other kinds of monsters. And you'll get lots of monster opportunities in our exercise today. When you're using figures on any kind of open table or floor, you must measure distances. In this case, I'm using a yardstick to measure metric distances. That's commonly used in tabletop wargaming, but you could be working in inches or using some other instrument other than a meter stick. You've got to figure out maneuvering. You've got to figure out things called firing arcs that must be measured. Often using some kind of maneuvering wheel or some kind of maneuvering arcs to determine how the units are able to move. And you can tweak those, things that come out of physical games, to experiment with what, if I change this, make this unit maneuver a little faster, make it maybe move slower but turn faster, or move faster and turn slower. What effect does that have on the game? You can experiment with that when you're using your toys. And often we use something called a firing cone when we're using toys to represent a unit or figures to represent a unit, and say that the weapons can fire anywhere within that triangular region called the firing cone. All right, when we're using square grids, I'm not sure if the camera's picking up, but these figures are on a square grid. They're like 1-inch grid lines going both ways, kind of a checkerboard sort of thing. And when you're using square grids, it's very easy to work in straight and perpendicular lines. But when you're using a diagonal, as in the case of this unit down here, square grids running this way, and this unit up here, trying to figure out the range between them, well, when we're doing that, we have to use a little thing called the Pythagorean theorem, where we have the calculation of the hypotenuse versus the rise and the run of the triangle. And that's, in this case, it's 10 units this way, 7 units this way, 10 squared plus 7 squared, take the square root, you get 12.2 units between these two units. I hope you've seen the Pythagorean theorem before. If you're going to write computer games in a computer, you will probably use that, because everything in the computer is generally in square grids. All right, straight line facing is very easy when you're using square grids. This airplane is clearly behind this airplane, moving in a straight line. But when the facing is not straight, it gets a little trickier. You end up asking the question, can that fighter here shoot its guns at that bomber from that position? Well, you've got to come up with the rules for that. You've got to think about how those things are going to work in your game, and the toys can force you to do that. Consider that. So if the fighter were to fire straight ahead, it would miss, obviously. But if you say that there's some fudge factor there, some wiggle room, a certain number of degrees, maybe that fighter can hit that bomber from where it is. Or do your rules say the fighter can turn in time to shoot? That will be for you to determine in your game mechanics. We learn a lot of this stuff from the tabletop war games that have been going on for decades and decades before we had microcomputers. Many of those tabletop war games use this thing called a hex map. How many people have played a game using a hex map in this room? Hands up. A few have. Interesting. Yeah, hex map has conventions that are helpful to us. Here's the conventions as described in this Battlestar Galactica game by FASA, where we had, you may remember this picture before, 2 Colonial Vipers in one corner, 6 Cylon Raiders in the other corner, and for terrain we had a planet and a moon. And you can see those Vipers near the planet there. And the planet is represented by a half foam ball that's been painted. And the spaceships are represented by cardboard counters on a black hex map. The physical prototype can help to establish a viewpoint, help to see what it looks like to be the Cylon Raiders, for example. Let's talk about some of the Hex Map Conventions. They have a facing, a direction that, a hex side that the unit is facing toward. You count ranges many different ways. If we go back here, the range between this unit and this unit would be, you either count the unit, count the hex that you're starting in or the hex you're ending in, but not both. So this would be 1, 2, 3, 4, or 1, 2, 3, 4. Either way, that range is 4. The range from this one to this one, not so straight, but you can count either way. 1, 2, 3, or 1, 2, 3. You get the same thing. That's a neat thing about hex maps. There is no right or wrong way to count. As long as you keep getting closer to the target, you will always get the same range count. So that's counting ranges. Moving forward is pretty easy to understand. The unit moves into the next hex facing. Side slipping would mean, oops, I went back too far. If this unit were to side slip to the left, it would move from this hex to that hex without changing its facing. So it would continue facing in that direction. Almost done with hex maps. Changing facing would be turning. You could have frequently written movement where you're using a hex map, which would be 3 ahead, turn left, move 2 more, things like that. Or vectored movement where the units are moving at the same time based on their speed. If you want to know about that, I can elaborate on that. It's kind of hard to demonstrate. And Hex Map Conventions games are usually turn-based games, but not necessarily. If you use vectored movement, you could conceivably make it continuous. All right, let's talk a little more about physical prototyping. The physical prototyping will not replace the 3D environment used in a 3D game. So these toys will not completely replace the figure running around in the 3D world. That is not its intention. You are not making the exact same game. But it can tremendously help in the early stages of a game's development to get your concepts down and mostly to communicate your ideas, as we'll repeat shortly. And to get an idea of what the game looks like and be able to communicate that idea too. It allows you to think through the way the elements of the game are going to interact with each other, adding to each other, attacking each other, whatever else they may be doing to each other. And it helps you to describe your ideas to the programming team. In this case of Lego Star Wars, this is what the game ended up looking like. I might have described this scene to my programming team using this rhinoceros, this Indian Brave, and this tank toy here. And we could have discussed, well, where's the camera going to be? Where's the player going to be? How are the different items going to move? And using the toys, you could work that out and end up with the product looking the way you both wanted it to. In the home stretch now, physical prototyping can allow you to visualize the core gameplay. That's probably the most important thing. And what is core gameplay? Core gameplay is the actions that the player will repeat the most often. In the case of the Halo games, there's that golden triangle of actions the player goes through with their controller, where they go through melee weapons, grenades, melee weapons, grenades. And that's famous to players. And they worked that out using physical prototyping. Okay, that's it for this week. I'll see you all in lab. Next week, we're going to talk about functionality, completeness, and balance. So until next time, this is Mike Substelny signing off from Intro to Computer Games and Simulations at Lorain County Community College.